Have you ever tried to jump off of a skateboard or a boat and have it shoot out behind you and fall flat on your face? Why does that happen? Hi, today we're going to take a look at Newton's third law and collisions. So, collisions involving a vehicle include three different classes of collisions: the primary collision, which is where the vehicle collides with another object, a secondary collision, where the occupant collides with the interior of the vehicle, and a tertiary collision, where the organs of the occupant collide with the body. So, different technologies identified in the table below are designed to reduce injury in a motor vehicle collision. So, we're going to identify if they're for primary or secondary collisions. So, shock absorbing bumpers would be to protect against a first class of collision. Crumple zones, again, a first class of collision. We're going to prevent and slow down the amount of time it takes a vehicle to hit another object. Padded dashboard and steering wheel. This would be for the second class of collision because it affects the passenger in the vehicle. Same with seatbelts, which are designed to slow down the passenger, as well as airbags, which are designed to increase the amount of time it takes for a passenger to come to a complete stop. So in a collision, think about what would happen if a car driving down the street loses control and hits a pedestrian. That car will apply an enormous amount of force on the pedestrian, most likely causing injury. The pedestrian is also going to apply a force on the car, which is going to cause some front end damage to the vehicle, denting the hood, or cracking the windshield, maybe breaking a light. So the car applies a force on the pedestrian, and the pedestrian also applies a force onto the car. This concept is summarized in Newton's third law of motion. Whenever one object exerts a force on another object, that second object is going to exert an equal but opposite force on the first one. So you can also hear this in the statement: for every action, there is an equal and opposite reaction. And this is shown by the equation F1 on 2 equals negative F2 on 1. The negative indicates that although the force values are the same, they're in the opposite direction from one another. So if two people on skates hold two ends of a rope, identify the action and reaction force when the person on the right pulls on the rope. So when that person on the right pulls on the rope, he is making the action force. The direction of motion is going to be to pull the second skater towards his body. And that is going to be the force of the reaction. To identify the force action and reaction force in this situation, as the person steps onto the pier, their reaction force is going forward and is going to cause the action of the boat to go backwards. The action force here is going to be the force of the airbag on the person, and the reaction force is the force of the person on the airbag. In this collision, the action force is the force of the bumper on the concrete, and the reaction is the barrier onto the bumper. When you're hiking, your action is the force pushing your feet against the ground, and then the reaction is the force of the ground holding you up. While moving forward in a car, a tire pushes against the ground, causing the action force, and the reaction is the force of the ground on the tire. So all these forces happen in opposite directions and are equal. So in an interaction between a large vehicle and a smaller vehicle, state whether or not the following quantities must be the same for each vehicle. So, mass. They must be different because the vehicles are different. They're going to have different masses. The velocity for the different vehicles should be different because they're traveling independently, so their change in velocity will not be the same. Their acceleration or deceleration is going to be different because they have different initial and final velocities. The time of the collision is going to be the same because the forces can only act when the two vehicles are touching. Therefore, the change in time interval is equal. The force acting on each vehicle is going to be the same because force 1 on 2 is the same as force 2 on 1, except in the opposite direction. The impulse is going to be the same, and so is the change in momentum. The change in momentum is going to be the same because if the force and the change in time are the same, then the change in momentum must be the same. And therefore, because impulse is equal to change in momentum, the impulse will also be the same. So that's our look at collisions using Newton's law of motion.